Yo, what's up guys? Welcome back to another video. And today we're going to be talking about general antiderivatives, aka the integral. So I think you already know what a derivative is. As you click on this video, it's just a slope or how something changes in a function. The antiderivative is something similar according to the function, but essentially it's just the opposite of a derivative, an antiderivative, you would say. So how we would notate it would be, instead of a little f of x, it would be like a big f of x, or anything else that you want to notate it as. The real big difference between an integral, the antiderivative, between a derivative, is just how we get them. So with a derivative, you will use power rule. We said we had x to the n, and then from here, for a derivative, you would do n minus 1. But first, you would bring down the n. So that's how it looked like. For the antiderivative, it looks something similar to it. You have x to the n. But then, instead of doing minus 1, you would do plus 1. And then from here, you would also divide it by n plus 1. That's essentially what the antiderivative is. And I'll show you why it works. So let's say we had, f of x equal to 1/2 x squared. If we were to find f prime of x, we would bring down the 2 and then subtract by 1. So when your derivative would just be x. If we were to find the antiderivative of x, we would just do x to the 1 plus 1 and then divide by 1 plus 1, which is equal to x squared over 2, which is the same thing as 1/2 x squared, because it's just different. The fractions are just kind of different. But that's essentially the whole thing. The antiderivative is just the opposite of deriving something. That's really it. And for integrals, we get into area, we get into volume, all that good stuff. But right now, we're just talking about general antiderivatives. Another rule of thumb to always follow is to always put this important notation. I'm gonna put like a little star. And that is to always put plus c if it's a general antiderivative. What do I mean by that? Well, what plus c means is that c is a constant. You might be wondering, well, it might not be that important since it's only the x function. But here's what I mean by that. Let's say we had the function f of x is equal to 1/3 x to the third plus 5. If we were to take the derivative of this function, we will get x squared. However, and here's the thing, if we were to take the integral of x squared, you would see that we don't get the 5 back. And as in calculus, we have to assume that whenever we take the general antiderivative of something, we have to assume that there will always be a constant such as c in the function. And the reason why we do that is because when we take the derivative of a constant, we just get 0, so it doesn't get included into the derivative. However, when we take the integral back, unless you are specifically doing a boundary problem or you doing a definite integral, which is what we talk about later, you won't get that constant back. So you have to put plus c, or else you will lose a point in your math tests, in your endeavors in calculus, if you don't put that plus c. It's very, very important that you put that plus c. So let's do some examples of some antiderivatives. Say we had the function f of x is equal to 1/2 x squared plus x plus 5. So what we do here is just do the same thing that we've been doing. Big F is equal to 1/2 x squared, but we have to do x2 plus 1 all over 2 plus 1 plus x to the 1 plus 1 all over 1 plus 1 plus 5. And this is very important that you know this. Whenever we take the integral of a constant, what we just do is we just add x. The reason why we do that is because we just assume that there's an invisible x to the 0. But x to the 0 is always equal to 1. In fact, anything equal to 0 is always equal to 1. So that's why we just put x at the front of it, of a constant. Because we just assume that you do x to the 0 plus 1 all over 1, which would just be 5x. But essentially, we simplify everything down. 1/2 times 1/3 x to the third plus x squared over 2 plus 5x, and we continue simplifying until you get 1 over 6 x to the third plus x squared over 2 plus 5x. And don't you forget that c. Do not forget that c. Very, very important that you always put plus c in order to represent a constant that might or might not be there. It might not be there, who knows, who cares? Like, just put it anyway. But essentially, that's how you find an antiderivative for a polynomial function. You might assume that we might have to put plus c's on all the functions, but in reality, since this is a function, we're just gonna have the same plus c always. We're gonna have the same constant. So instead of putting, plus c, plus c, plus c for all of them, we don't do that. We just put 1 plus c at the end to represent the constant, and that's it. So let's go to another example. And this is very important. Let's say we had the function e to the x. Now, since we're not doing u sub in this video, we're not going to do e to the 2x or something like that. No, we're not going to do that. We're just going to talk about e to the x. So you would know that the derivative of e to the x is just e to the x. However, big F of x is just equal to e to the x plus c. So always remember that. It doesn't matter what function it is, even if it's, a special function such as e to the x, you always put plus c in front of it. And so now let's get to another special function. F of x is equal to 1 over x. You can't really do power rule, the power rule or the antiderivative rule with this one, since you must always know that natural log of x, the derivative, is equal to 1 over x. But there's a special function with this one. When you take the antiderivative of 1 over x, what you get is not simply just natural log of x, but natural log absolute value of x plus c. Always very, very important that you put the absolute value in front of it. I can't tell you why we do it. All I know is that you just have to do it, and it's kind of important for you to do it. So now let's go to another example, shall we? Let's say we had f of x is equal to x squared plus x plus 1 all over x. You might be wondering to yourself, well, how can we find this antiderivative? We have so many things that we have to take care of. And if you're advanced, we can't do u sub. We can't do partial decomposition. You might not know what that is. Don't worry about it. There's a simple answer to this. What we can do here is we can just separate the variables. Here's what I mean. We know that all of these three things, the trinomial is going to have the same denominator. So why not? Oh my God, I started dying. Why not just separate them like this? The reason why you're able to do that is because they're all the same common denominator. Therefore, you can separate them because it's not the numerator that you have to worry about, it's a denominator. But for here, if you add all these up, you'll get the same function all over again. But this time, it makes it much easier for us to find the antiderivative of. So what we just cancel everything out. So then our f of x is equal to x plus 1 over x. And from here, we can individually find every antiderivative. So we have big F is equal to 1/2 x squared plus x plus natural log value of x. Now let's go talk about some natural log rules. Essentially, this is the last thing we'll be talking about, but you might see a difference with, let's say we had f of x is equal to 5 to the x. When you find the derivative of this, it'll be 5 to the x, you keep it the same, times natural log of 5. For the antiderivative, so let's say you had f of x is equal to 5 to the x. What you would do here is instead of multiplying it, what you would do is you would actually divide by it. Reason why you do that is because when you take the derivative of it, so let's say you have f prime of x, well, big F prime of x is equal to 5 to the x natural log of 5 times natural log of 5 equal to 5 to the x. That's essentially what you would do. I might be wrong for this one. I do not quite remember. But essentially, it's just doing the opposite order of the antiderivative for all of them. So that has been the video. Hopefully you enjoyed. Please like, share, subscribe. And if I messed up somewhere, please tell me. I'm not perfect. Calculus is very, very hard. So we'll go through it together. Do not worry. Thank you for watching, and goodbye.